Petrology is the branch of geology that studies the origin, composition, distribution and structure of rocks. Lithology was once approximately synonymous with petrography, but in current usage, lithology focuses on macroscopic hand sample or outcrop-scale description of rocks, while petrography is the speciality that deals with microscopic details. In the petroleum industry, lithology, or more specifically mud logging, is the graphic representation of geological formations being drilled through, and drawn on a log called a mud log. As the cuttings are circulated out of the borehole, they are sampled, examined and tested chemically when needed. Methodology: petrology utilizes the classical fields of mineralogy, petrography, optical mineralogy, and chemical analysis to describe the composition and texture of rocks. Modern petrologists also include the principles of geochemistry and geophysics through the study of geochemical trends and cycles and the use of thermodynamic data and experiments in order to better understand the origins of rocks. Branches: there are 3 branches of petrology, corresponding to the 3 types of rocks: igneous, metamorphic, and sedimentary, and another dealing with experimental techniques. Igneous petrology focuses on the composition and texture of igneous rocks. Igneous rocks include volcanic and plutonic rocks. Sedimentary petrology focuses on the composition and texture of sedimentary rocks. Metamorphic petrology focuses on the composition and texture of metamorphic rocks. Experimental petrology employs high-pressure, high-temperature apparatus to investigate the geochemistry and phase relations of natural or synthetic materials at elevated pressures and temperatures. Experiments are particularly useful for investigating rocks of the lower crust and upper mantle that rarely survive the journey to the surface in pristine condition. They are also one of the prime sources of information about completely inaccessible rocks such as those in the Earth's lower mantle and in the mantles of the other terrestrial planets and the Moon. The work of experimental petrologists has laid a foundation on which modern understanding of igneous and metamorphic processes has been built. See also: Important publications in petrology, or references. Best, Myron G., Igneous and Metamorphic Petrology. ISBN 1-4051-0588-7, Blatt, Harvey. Tracy, Robert J. Owens, Brent, Petrology, Igneous, Sedimentary, and Metamorphic. ISBN 978-0-7167, 3743-8, Dietrich, Richard Vincent. Skinner, Brian J., Gems, Granites, and Gravels, Knowing and Using Rocks and Minerals. ISBN 978-0-521-10722-8, Free, Einway. Bertka, Constance M. Meissen, Bjorno, Mantle Petrology, Field Observations and High-Pressure Experimentation. ISBN 0-941809-05-6, Philpotts, Anthony. Ague, J., Principles of Igneous and Metamorphic Petrology. ISBN 978-0-521-88006-0, Robb, L., Introduction to Ore Forming Processes. ISBN 978-0-632-06378-9. External links: Atlas of Igneous and Metamorphic Rocks, Minerals, and Textures, Geology Department, University of North Carolina, Metamorphic Petrology Database, Department of Earth and Environmental Sciences, Rensselaer Polytechnic Institute, Petrological Database of the Ocean Floor, Center for International Earth Science Information Network, Columbia University.